You learned frameworks and reuse, Tyler. So what is a framework?
Kind of a base for everything to build off of.
Okay, a base to build on. Okay, great.
Like the framework of a house.
Like the framework of a house. Okay, all right. All right. So then, how do interfaces and abstract classes work with frameworks?
Your interface helps you interact with your framework.
All right, so we'll get started.
Let's learn.
Let's go ahead and start learning. So what is a framework, Tyler? The author did a hand-in-hand concept of code reuse and standardization, sometimes called plug and play. The idea of a framework is you basically sitting down and you're coming up with an acceptable way to move data around, how to communicate from one object to another, and you have a framework that does all the the heavy lifting for you. And so you just have to specify how the specifics work. There's a lot of frameworks out there. You start looking in OOP, there's Spring frameworks, there's all sorts of frameworks out there. Yeah, so right now we talked about inheritance and composition, which basically are reused for one class of the hierarchy. The framework is just to still start building up the idea of now you're going to reuse the entire system. Although you can still kind of do that with classes. The idea is when you use the word framework, you really need to think of someone's trying to solve a huge problem, and they came up with a framework in order to do it. Okay, the contract. Wow, we're just going to throw a lot of terms out here. So if you have a class, what part of the class do you think is the contract? Or what is the contract we're talking about here?
So it would be like the attributes?
Sort of the attribute. Okay, so which ones? So if there's a contract, it's some agreement between one object and another, right? How they're going to interact with each other. So how do you open that up between one object and another?
Is it kind of like when we have a constructor and we set it equal to something?
Okay, yeah. Right, because other objects or other programmers are going to have access to your constructor. So that's the constructor is definitely part of your contract, basically labeling how you can create or construct the object. So good, yeah, that's one thing. What else would be part of the contract? Let's jump over here. Let's see. Employee. What part of this employee is would you say, is part of the contract, i.e. what other objects have access to?
Methods.
All right, which methods? Did that help any, or is everyone going to sleep?
No, no problem.
I'm happy.
You're happy? It's a good day.
Give salary, good ID, good job title.
Correct. Those are part of the contract. Why are they part of the contract?
Public.
They're public, right. So your contract is really your public methods or your public data types, but you should really only have your public methods. Because if I wrote a private method inside of employee, only employee would have access to it. So it wouldn't be part of a contract with another object. But by making something public, you're essentially saying other objects are allowed to use this functionality. Sometimes referred to as an API, application for, was it programming interface? Okay. Thanks, dictionary.com. All right, yeah, so this term is used a lot. Don't confuse it with the legal term. But in software design, they're talking about contracts. Basically, the enforcement of the contract is vital. How do you interact between one and another? Abstract classes. Okay, great. Here we go. One way a contract is implemented is via an abstract class. So an abstract class contains one or more methods that do not have any implementation provided. Ooh, why would we want to have that?
If you do that, you can use them for other classes.
Okay.
You have other stuff you want to put into it.
All right. Well, sounds like it's time to start coming up with an example. What example would y'all like today?
For inheritance?
Yeah, I'll come up with something for abstract classes.
Wait, what's our next lab on?
What's our next lab about?
Yeah.
Yeah, you can't choose that one. Good try. I will say no.
Like family.
A family. Let's see. Family. Okay. Yeah, that doesn't quite work because family members can't be abstract.
Well, they could be adopted.
Adopt well.
A class, like school.
We
But-
can go with a new example.
Wow. Let's see. Okay. Okay. Let's see. Actually, let's see if the slides. I haven't looked at these yet. Nope. Nothing. No. Thanks. Great. All right. Shape circle. Oh, really? That's the one we have inside of our class day. So that was a shape because a shape is abstract. It's not actually a concrete shape, unlike a circle or a rectangle, which is a shape, which is an actual shape. So I was trying to think of how that would work with person.
Well, kind of tell us what you want.
Right. Let's try to drive another example here. So with shape, a shape could be anything, right? And then a rectangle or a circle is an actual, it specifies the exactly what that shape is.
So could we do vehicles?
Sure, we could do vehicles. So yeah, let's do vehicle. I like it.
Yeah, let's do cars.
Let's do cars.
Okay, race cars.
All right, so we have vehicle. Add that guy to Git. Okay. So, what would a vehicle have that we want?
Wheels.
Wheels.
Big engine.
Well, hold on. Not all vehicles have wheels.
Okay.
What if they're, what is it called? Is it tread or track?
Tracks.
Tracks, thank you, tracks.
So all vehicles have an engine of some sort.
Hopefully, okay. Okay.
We're not doing the whole motor versus engine thing, are we?
No.
Okay, cool. So, yeah, let's go with engine.
Let's go with engine. Okay.
Right?
All right.
Motors are electric motors.
So, public, abstract. Well, yeah, it's going to have an engine, but what's an action that a vehicle can take?
Moves, it drives.
It drives, okay.
Not all can drive, right? Some can fly.
Some of them fly.
Oh, yeah.
Man, we went really abstract this time. Oh, but that's great. I like that. Let's do that. So we could have public, abstract, what do we say? Fly?
Yeah.
Fly. Right, because abstract's not allowed there because I subconsciously put the word public.
Mm.
Oh, okay. There. Public abstract class vehicle, abstract void fly. All right. Well, we just did something interesting here. Abstract void drive, and we'll just give it a string location. Let's pass a string location of both of these so we know where we're going. All right. So I've declared the class abstract and I've declared fly and drive both abstract. Can anyone tell me something very different besides the word abstract here between these functions and our other functions?
Void.
Yeah, they're not returning these values.
They don't return a value, true, but I have
String
other
location.
functions that don't return a value. String location, both being passed a string, but I have other functions that are passed a string.
Oh, you're not returning. Well, there's just
Well, I'm
like
not
inside it,
return-
I don't know. You're stuffing it. You're
I'm stubbing it out. There's no implementation here. So there's no implementation. Okay. Let's go back to our, let's get a better name here, like abstract main. Abstract main. Ooh, the abstract man. Let's go and fix that real quick.
Just leave it. It's cool, right?
You could what?
Just leave it. It's cool, right?
Yeah, I could. But the two people that sat there last time would not allow it. So we're going to go ahead and fix the names. Args. Alright. So I could initialize vehicle V, or lowercase vehicle, and that's perfectly okay. Because what am I saying? I'm saying vehicle is a variable on the stack that's going to point to something that's type vehicle. So that's okay. But could I do vehicle equals new vehicle? Yeah, maybe if I spelled vehicle correctly. Yeah, it's giving me red. Why is it giving me red? Can anyone take a guess?
Is capital V?
Well, I haven't made it constructed.
Haven't made a constructor. Alright. Okay. Still red. Any guesses?
You have to instantiate the methods that.
Have to instantiate the methods. I like where you're going with that. Yeah, the problem is abstract can't be instantiated. Java doesn't have any code to run on a vehicle, so it can't instantiate a vehicle object. All right. So what if we made, I don't know, I'll make a new class. Whoops, that was a file. New Java class. I'm going to call it a ground car, since flying cars seem to not be too far in the future. And we'll have it extends vehicle. Alright, it's going to give me some red because ground car must either be declared abstract or implement the abstract methods inside of it. In other words, Java says you have to either a class has to be abstract or have an actual implementation for everything that it inherits. So if I were to go Alt-Enter here and tell it to go ahead and implement the methods, we'll go and implement all of them. I'm going to get rid of this vehicle constructor function because it's not that useful. Okay, ground car extends vehicle. So now the red's gone away because I actually have the two functions, fly and drive. Notice that over here in vehicle, I say fly and drive are abstract, and over here in ground car, I have to implement it. In other words, when you say something's abstract, you're saying anything that inherits from me has to implement these functions. Yes?
So say you made the ground car abstract, and
Okay.
you instantiated one of the methods.
That's, yes?
Then, and then you went over to main. Would main still give you an error then?
Right, okay, so let's go ahead and go with that example. I'm going to go over here, I'm going to rename this. Where am I? Right, so actually I'll just show you because I think that would be a little clearer. Don't want to get too confusing. If I'm here inside vehicle, the point is now I could make a new ground car and it would be okay. Because ground car is an actual realization, it's not an abstract class. You can actually instantiate it. And then I can set vehicle to point to that. Why is that okay?
Because it inherits from vehicle.
Right, because a ground car is a vehicle. All right. What Alex was asking is that if I was inside of ground car and I made public abstract class ground car and maybe deleted the fly function, over here in main, would it still be okay? No. because the class is now abstract. So you can't instantiate an abstract class. It has to have implementation.
What if you just made abstract and both of them in there? Then it would still be.
Oh, if I made them abstract and did this?
Yeah.
So the problem still is by declaring this abstract, Java will not allow you to instantiate it. But we don't need it anymore because we actually have the function implemented. So I'll just say system.out.println, I'm going nowhere. For flying, and then for driving, I'll just say I'm on my way to location. All right. So I'm down here. I can then try and do vehicle.fly. Gotta give it a place. Now let's say CSU. We'll go ahead and run it. Where's run? All right, I'm not going anywhere because it can't fly. It's a ground vehicle. Okay. Or a ground car. All right. Let me think. One other thing. See a couple other things. Let's see. If we're over here inside of vehicle, fly and drive, what you can do is you can do something inside of an abstract class. What makes these kind of powerful is not everything has to be abstract. For example, I could give it a private string name, and then maybe I'll give it a public void set name, and then this one I can just have mname equals name. Of course, name should be what's being passed in, and then I could also do public void get name, return name, or mname. So the vehicle is abstract. Did I misspell something? Oh. It should return string. So the vehicle is abstract, but I can still implement some of the methods. So a ground car over here actually has those methods, because I can go back to vehicle, abstract main, and do vehicle.setName. And I'll just do, what car should this be, Tyler?
Trans Am.
Trans Am. That one has a dash in it, right?
Yeah,
Okay, good.
sweet.
And I'll do system.out.println. Let me spell println correctly. I'll go vehicle.getName is trying to fly. And that way when I run it, I can still get the Trans Am is trying to fly, but he's not going anywhere. So I just wanted to show you that, hey, look, when you extend a vehicle, even if vehicle is abstract, you can still put some of the implementation in a base class, and then maybe not have any implementation for the child class. Okay? Okay. Lastly, one thing I want to show you is that inside of ground car, I could public void set name, passing in the name, and then I could have mname equals name plus vehicle. Although mname is private, so I'll have to go back here in the final and make it protected. Protected, so that, there we go, protected, so that mname actually has it. And I'm overriding the set name here. Alright, I'm going to take a step and see if y'all been following me. This is kind of a strange example, and the reason it's a little strange is abstract classes are kind of weird. when we get to interfaces, I think things are going to make a lot more sense. But I want to make sure, I want to see if everyone's following here. So let's go back to the main code and let's see what it's doing. So I created a variable called vehicle that's going to point to a vehicle object. Now what does this next line do?
Creates a ground car that is a vehicle.
That is a vehicle. Creates it, where does it allocate its memory? In the heap, and returns a pointer and stores that pointer in,
Stack.
which one? Returns the pointer to that object, and that pointer is stored inside of the variable
Ground car. I mean, vehicle.
vehicle, lowercase vehicle. Okay? Vehicle.setName. What function is being called? Vehicle has a set name, and ground car has a set name. Which one's being called? Notice that vehicle over here has the same method signature as the one inside of ground car.
It's going to call the one in ground car, right? Because it wasn't a vehicle in ground car.
Yes. So since it's actually a ground car, it's going to call ground car's function. Over here with ground car, I guess I shouldn't say vehicle, I should say car. So it's going to take its name, Trans Am, concatenate car,
Yay.
and then what is it going to print out here?
Trans Am was trying. Trans Am car is trying to fly.
Right, Trans Am car is trying to fly.
And you can do that.
You- It'll try.
It'll get pretty close. It'll take off.
Was it a Trans Am and Knight Rider? Was that one?
Yep.
Yeah, okay, that's what I thought. Yeah. That one didn't fly.
But you're giving it like this much of a bump in the road.
Oh yeah, then just took
Well,
off,
I
right?
guarantee I can
Yeah.
fly.
You'll land hard too.
Yeah.
Hey, when I'm on the track, as soon as I stop the gas, the wheels come off the ground, so
No.
it starts to fly.
Okay. Oh, so you have a Trans Am? Oh, okay, cool. All right. Any questions about this example? Abstract classes are a little weird, but some people use them a lot.
Better Trans Am, Smokey and the Bandit. Bandit Trans Am.
Oh yeah.
Nicest car.
Will we use abstract classes a lot?
You will use them in the next lab, and then I will probably never use them again.
Have they used that often?
So abstract classes versus interfaces is what the debate is, and it really depends on who you're working under, which one they're going to do. Some programmers are all about abstract classes, some are about interfaces. I tend towards interfaces because I believe the division is cleaner. I'll talk about them in a bit. But also the Java library uses interfaces. So to me, the decision's been made, right?
Abstract just kind of seems like a hassle. Having to implement methods that you might not even use.
Right. Yeah, it's
Like a car is obviously not going to fly.
right. This example, I'm glad you pointed that out. So yeah, trying to get a car to fly, that's a terrible design decision. And
Indeed.
indeed. So that's actually a good thing to point out. So if I had fly right there, yeah, all vehicle implementing this function fly is actually pretty bad. Okay. Abstract, framework, caution. Okay. So the book uses shape, circle, and rectangle, which we will be using in our lab. But I wanted to show that this is not a strict contract, because actually, can anyone take a guess why this is not a strict contract?
Could you repeat the question?
Yes. I want to make sure I draw the conclusion, the division between what a contract actually is and what's going on with abstract classes. Is this a pure contract? Is it, in other words, is vehicle just telling you how I mean, just telling you what you can use when you interface with a vehicle. So it does tell you fly and drive, but the problem is that it's implementing some of it. So it's not just a contract, it's a contract plus an implementation. So it's not a pure contract, and that's why that's where the debate between interfaces and abstract classes are. Because an interface, it's a pure contract. You are strictly not allowed to implement anything. But in abstract, you can have this hybrid. So the idea is with interfaces, it's a strong division. Okay. Protocols. All right, let's just go over to interfaces. Let's go with another example. This one I'm going to try and be a little bit cleaner. All right, we're going to do bird. And I'll make it an interface. When you declare something an interface, you don't have to put the word abstract anywhere. Everything is abstract no matter what you do. So, what can a bird do? Do all birds fly?
No.
No. So that is actually a poor thing to put in a bird interface. But what do all birds? Do all birds have wings?
And they lay eggs.
Yeah.
They lay eggs. Okay. Okay. Let's see. How about an action? Let's do
They
an action.
shed feathers.
Huh? They shed feathers. All right. And maybe they shed them at different rates. Hmm? Okay, public int shed feathers. And actually we don't need public because it's redundant. If it's an interface, everything is public abstract. So we had shed feathers, we had void eat, and let's also make what type of noise? They don't all quack, but they all make a noise, right? Screech. Do they all screech?
Screech. I don't know. Do all birds?
I'll just do make noise.
Oh yeah, I guess you could do like.
All right. Now, so, oh, any other questions? Trying to make this one simple. All right. Now notice I love the fly example here because a bird, not all birds fly. But there's actually an easy way to enforce that. We can make a different interface. And we'll call it flying bird.
So it'll inherit its stuff from another one?
So it's still an interface. It's going to, what was it? Is it extends bird? Hope I got that right. Is that right? Excellent, awesome. But since it's a flying bird, obviously it's able to fly. All right, so then we'll have void fly. We'll just give it some location. Okay, but since it's an interface, it can't just, you don't implement anything, you just make it void. Let me make sure this is explicit. I'll go back here in bird. Let's see. By making bird an interface, it is abstract. Now, since bird is an interface, all methods are public abstract. So you don't need to do public abstract int because that is completely redundant, and even IntelliJ just tells you. So I just wanted to make sure that that's perfectly clear. They're all abstract. Since everything's abstract, can you implement anything in here? No. You're not allowed to implement anything. Okay. Well, we have a bird and we have a flying bird. Let's go back to, well, we had an abstract main. So let's go and do an interface main. Yep. All right. So we'll have flying bird duck. And duck equals new. Can we do flying bird?
Yeah.
What did you just say, bird?
Right, it's abstract. So since it's abstract, we have to actually implement it. So we should probably come up with another class. Let's go ahead and make a duck. Now, when you do interfaces, you don't extend an interface, you implement an interface. So it's implements flying bird. Now it's going to give me a problem because it says, whoa, whoa, duck must either be declared abstract or implement the abstract method. So I'm going to put my cursor over it. Notice my cursor is where the red is. I hold down Alt, I hit Enter, and then the little menu comes up. I'm going to click on Implement Methods, and it's going to say, hey, look, you have to implement these 3 methods from bird and that method from flying bird. Do you see why it has to implement all those methods? All right, since flying bird inherited from bird, you need to implement both of those. Okay. So we're just going to give it some simple code for flying. Duck is on its way to plus location. How many feathers do you think it'll shed?
7.
7. Awesome. System.out.println. It'll just say food, just for lack of imagination. And make noise. Oh, this should be easy. Screech. I thought they do more of a quack. Screech. All right, we'll do quack. So we'll have quack, screech. Is that how you spell screech?
Maybe 2.
I think it's 2 E's.
2 E's. Oh, good. Quack, screech, quack. Great. Okay. So I've just implemented some stuff right there. Wow, we need to get rid of some of these other windows. There we go. Interface main. So I can't do that. Not allowed. But if I want duck to actually be created, maybe it's a new duck. Oh, what's the problem here? Come on. Return type required. Did I misspell duck?
You have to do the duck you're talking about? Capital D?
Duck equals new duck.
I think that's what we're missing. You're not telling what type it is.
Hold on, it's actually have a problem with the new. It's acting like the we never added a constructor. Okay, public duck. There, we have a constructor. Let's see, invalid method declaration return type required.
Yeah, can't you do capital duck?
Yeah, isn't that a capital D duck?
No, just
Duck equals new duck. That's what he wants you to do.
This should not be causing. Add method body. Doesn't make any sense. Public class. Oh. Wow. All right. Public. I never made the main function. String args. Whew, that was bad. Okay, flying duck. Duck can't equal new flying bird because flying bird's abstract. But if I do duck equals new duck, we're still good to go. There we are. Now, why is this okay? Because lowercase duck is pointing to a flying bird. And so, but capital D duck's returning a duck. And this is okay because,
Not abstract.
right, it's not abstract. Duck's not abstract, so we can instantiate duck. And duck is a flying bird. We have that inheritance model there. So it's okay that we're pointing to it. Now, since lowercase d duck is a flying bird, I can do duck.fly. I'll say CSU. And I can also do duck.makeNoise. And now let's go ahead and run interface main. That's not what I meant to do. There it is. It's on its way to CSU, quack, screech, quack. Where's it going?
Screech.
Hurry.
He's inbound. Duck inbound.
Duck inbound to CSU, watch out. Everyone prepare. All right. Any questions so far? All right. Let me think here for a moment for where we should go next. If I change flying bird to bird, would I have any errors?
Yeah, because this is flying bird.
Right, so where would the error be?
The places you have flying bird.
No, hold on. Okay, right now I have flying. Right, if I change this to just bird, where would the error be? Well, it's going to pop up now.
Fly.
Why is that an error?
Because bird can't fly.
Because bird, a bird has not been defined to fly. Hence why I made the interface flying bird. Flying bird. There we go. So then we're okay. All right. So the interface really is the contract, so to speak. A better definition of what a contract is.
Oh,
Someone have a question? Okay. In general, that's what's being used, are these okay, you call them protocols, but these interfaces are what's being used inside the Java language. So if I were to do Java list, where's list? Does that sound familiar? Something we've used? Array list. Interface list. Don't worry about that less than E greater than E. Just concentrate on interface list right now. All known implemented, well, you can have an array list, attribute list, a link list, a role list, a stack, a vector. These are all lists. So if you wanted to use just our standard list, which has these interfaces, you can create that list variable. For example, if we were back here, whoa, that should be full screen. That's okay. We're back here. I know this was a while ago, but I want to show you, where are we? Actually, it was the last class. I know, a while ago. And we had array list right here. Since list is an interface, we can just take array list out of here, Alt-Enter to go ahead and import it, save it, and all the code is fine. Because array list implements list, and all we've been using are the list interfaces. Now, so I'm using a list inside of employee directory, but inside of the constructor I'm creating an array list. Why is this powerful or useful? Or maybe I should ask this question differently. If I wanted to change to using a linked list, what would I change now?
You just change that.
Which line?
That line that you just changed from array list.
Oh no, because if this was linked list, and then we imported it, it'd have problems because you're trying to create an array list here. But if you keep it a linked list, all you have to change is this new right here to make it a linked list. Now we haven't talked about the difference between an array list or a linked list. But, well, does anyone remember? I guess from last
Wait,
time.
so you say list, so then you can be like any of those lists, right?
Any of those lists.
And then you say which kind of list.
Which kind later on. The point of this is as long as you stick with the list interfaces everywhere, you use an array list, and all of a sudden you realize, wait, the performance or the behavior of an array list does not match our performance requirements for our large program. You want to try it on a linked list, you just change it to new linked list, you hit go, now you have a different model altogether, a new backend. Or you can change it to a role-based list, or whatever other type of list you want. If you wanted to come up with your own list, all you had to do is create a class that inherited from list, or implement list, and now you can have your own way of adding and removing. That way, you're just plugging in, you're just having your separate code to do that particular role. Did y'all see that? That's probably the biggest thing here when it comes to inheritance, in my opinion, is the ability that as long as you stick with an interface, Later on, you might implement something else to give you better behaviors or perform the actions you desire, but still maintaining your legacy code. You just wrote something else and plugged it in. Any questions about what I just explained? I'll be going more examples along the way, but hopefully this is starting to click for y'all. Can't tell. I can't tell if this is like, yes, stop beating the dead horse, or, oh, I'm tired, it's Thursday, and the weekend's almost here.
We'll go with the second one.
The second one? Yeah, I had a feeling that was the case. Well, guys, we'll get through this on some labs, but if you understand this now, that's great. I think you're going to start cruising through the rest of the class, because we're really just exploring different techniques that utilize these technologies to make a more efficient or better coding environment. All right, let me just look through these slides. I'm not going to talk about protocols. I think you have way too many definitions in your head as it is, unless y'all think you want more. No, I didn't think so. Interfaces, we just talked about interfaces. Note that Java is not the only one that has interfaces. .NET, C, Objective-C, they're called protocols. I'm just going to say, for the sake of argument, they're the same thing. Most languages, any class or object-oriented programming language has an interface in it. We've talked about using the interface. It's the formal structure. If it makes sense, right. That's a good point. Let's pause for a moment here and compare. What do we have? We have bird and we have vehicle. Great. I'm really just trying to, let's see the best way. Which do y'all prefer? I've kind of showed them just briefly, both how they work. Which one do y'all actually prefer?
The interface seems to be like it fits together better.
The interface.
Abstract, I was totally lost when you were flipping back and forth.
Right. Okay. So the interface is easier to understand conceptually because you're just saying, well, you're only listing functions that you must implement, right? That's what an interface is. You must implement these functions. That's all it's saying. The abstract class
Jumps all around.
jumps all over. It can't decide if it's an interface or a class. Yeah. All right. So yeah, it sounds like you're saying the interface is better because it's simpler, it's easier to understand and follow. Okay.
So what are the pros of an abstract? I don't see
Over
the
an
point of it.
interface. Like, when would you say, I'm going to use this one, or I'm going to use this one, other than preference?
Other preference? Oh, okay. It is preference.
It's 100% preference?
Because you could create your abstract class and do public abstract all the way down in front of all your functions, right?
Okay.
The power of an abstract class is you can actually provide some of the implementation at some point, right, of what's going on down the hierarchy. So some people prefer to have that code inside of, up the chain at some point. Anyone else? I'm definitely on the inheritance interface side, so I probably steered you towards that. But some people will say abstract all the way, although the Java library, as I just showed you, uses interfaces.
So for our lab then, is it a choice or is it?
No, for this lab we're using abstract classes. You gotta learn it. You gotta learn it once. Make sure you understand it, and then it's interfaces all the way. For the win. Okay. Yeah, I do agree. Because the nice thing here, you have interface with bird. You have another interface that just, oh wait, I'm going to tack on this extra function, and then you can choose what you're actually implementing. And the Java library, when maybe we have some more time. List. Actually, these are the real classes, but list inherits from a collection. So it actually has all these public abstract methods as well. And it also inherits from iterable. So there's still an inheritance hierarchy with the interfaces, but it's it's just listing all the functions, and then all of a sudden you actually implement everything. Is the way the interfaces work. All right, let's make sure interfaces. We're going to talk about GUIs a little later. Oh, okay. That's another way to think of it. Abstract classes require a strict inheritance relationship and must be related and can provide implementation. Interfaces can be used for classes that are not related and do not provide implementation. All right, what does that mean? All right, so we got a bird. One thing I haven't touched base on, I'm trying to think of a good example here, is with abstract classes, you can only inherit from one abstract class. You are allowed to implement as many interfaces as you want. So you could have bird, I don't know, maybe you had a bird-reptile hybrid, right? So you could have the bird interface and the reptile interface, and then your hybrid would implement both of them. And that's perfectly fine, because since they're an interface, there's no code, you're just implementing methods. Java allows that. But the problem with abstract class, as you said, it gets complicated and confusing. I actually wish all books would teach interfaces first before they even try and do abstract classes. But this is just the way it's done. So with the abstract class, it's a little more confusing. Java's going to have a harder time deciding when to choose one over another. And let me go to the board and show you exactly what I mean, because this is actually very important. Okay. All right, we have class A on the board. Awesome. I'm going to leave it empty for now. We have class B extends A. Can leave it empty for now. We have class C, which extends A. I'm trying to show you why extends is confusing. And then we have class D extends. Now you can't do this in Java. Let's just say it could extend B and C. Okay? So what does that look like? Well, you have A, you have B, you have C, and then you have them both going to D. Right? Okay? Again, this can't be done. I'm trying to explain to you why extends is confusing. Let's say class A had, I don't know, we'll stick with our void fly. System.out.print line I. We'll say this guy had void run, no implementation, and this guy has void, let's see, fly with no implementation. And if I was inside class D and I had a void fly, but I wanted to call super.fly, what method am I calling? Do you have any idea? No. This is why it's multiple inheritance is usually thrown out, because this is just confusing beyond all belief. What am I even doing, right? Right. Do y'all see how this is kind of confusing? On the other hand, if we had this, interface, fly, class B extends A, we'll have interface, run extends A, so we can't implement run, and then we'll have interface extends A, And, well, it doesn't need to implement fly because it's already part of it. So we're done there. And then if we have class D implements, B and C, you can't call super.fly. So you just have to do system.out blah, 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 blah. And you would also have to do a void run. Am I off the board? I'm off the board. I'm ending my curly brackets for those of you online. So at least this makes some more sense, because all it's saying is that class D needs to implement the method fly and run. Right? That's all it's saying. Beforehand, which function fly am I calling? Right? What's going on? You kind of understand? This is called the diamond problem, because
It's a diamond.
it's a diamond. It's literally called the diamond problem. There are ways to figure it out and put errors that at least make some sense back to the programmer, but it's generally accepted that it's far more trouble than it's worth. So Java just doesn't inherently allow you to do this unless all these guys are interfaces. You can't do this last part unless both these guys are interfaces. Okay? Okay. All right, putting together interfaces. Right, just has implementation, not behavior. Good. They're the plug-in points. That's right, because we're literally plugging in the bird. And an even better example is right here. List is a plug-in point. We'll plug in our linked list, or maybe we want to plug in our array list, or maybe we want to plug in our row list, or maybe we want to plug in our own list that we develop. So it's a plug-in point. We're plugging in our implementation. Great. Any questions about that? Hopefully the next chapter is going to help bring this all together, and then we'll start talking about design patterns and how to use these tools we just learned to effectively write code. But any questions over this material? All right, let me pause the recording.